right, so we've already coded the insert and the peek methods. We've got our constructors in for this linked list class. We're going to finish this off by coding a remove method. That's the whole advantage of using linked lists, is you can add and remove to your list fairly easily. So let's code our remove, and we'll code our extraction operator, and this hopefully will pass all the tests. All right, so we need our templated class. We're going to say void linked list of that type remove. R-E-M-O-V-E. Can I spell remove? So we're going to remove from a particular index. They're going to give us which one they want removed, and then we're going to delete at that point. Okay, in order to count this, just like in our peek, we need a variable to represent which node we're on. So I'm going to say int current node num. That's starting out at 0. And then we also need a pointer for which current node we are. And this time I'm not going to put 3 R's in. Set that equal to the front. Okay, so now we have a couple of scenarios. We have if they're going to delete the front node. We need if the number is out of bounds, and then if they're going to delete any other node. And I'm actually going to reorder that. I'm going to say if they're out of bounds, if they give us a number that does not exist. So if ndx is greater than or equal to the number of nodes in our list, then that doesn't exist. You could go further and say if it's also a negative number, we don't accept negative numbers. I'm going to keep this as and then we'll just specify item does not exist. Okay, so that is our first exception, is if they happen to give us 15 and there's only 7 in our list. Okay, next we have to see if the item they're looking for is the front of the list. Deleting from the front of the list is just a little bit different, just because we have to modify the pointer to the front of the list. So if ndx is equal to 0, then I have to remove the front of my list. And I already have my current pointer pointing to the front of my list, so I can just move that front arrow. No, I'm going to set my front pointer equal to the second item in the list by saying front equals front arrow next. That way my pointer is now pointing to the second item in the list, and now that my pointer is pointing to the second item on the list, I can delete the first item in the list, which is what I'm looking for. Now I'm just going to say return so it doesn't continue executing the rest of the code. Okay, the last situation I've got if my number is not within the list. I've got if I'm deleting the front of the list. If it's anything other than the front of the list, I have to iterate through my my list. That way I can see where my current pointer is. So here I'm going to say, well, current node num is less than ndx minus 1. So I'm going to add 1 to my current node number, and then I'm going to move my current node number along. So current node equals current node arrow next. So this is going to keep counting up until I get to, it's not going to count up to the current node I want to delete. It's actually going to get 1 less than that. And the reason why I want 1 less than that is in order to delete the current node, I have to modify the previous pointer. So here I'm going to just mark this. I'm going to say auto, the one I'm going to delete, D-E-L-E-T. I'm going to set that equal to the next value of the current node. This is the one I want to delete, is the next value of the one, because I'm doing index minus 1. Okay, the next thing I'm going to do is I'm going to actually remove it from my list. I haven't deleted it yet. I'm just going to remove it from my list. Current node arrow next is equal to the one I'm going to delete, but not the one I'm going to delete. I'm going to set it equal to its own next value. So that way the current node next is skipping the to delete mode. It's going straight to its next value. And now that I have my whole list in order, now I can go ahead and delete the one I'm going to delete. And that is my remove method. Okay, the last thing I'm going to do is I'm going to code our extraction operator. So I still need my templated class, and I'm going to code my OStream. How about if I just copy and paste my OStream? That always has. Okay, I don't want this friend, so I'm going to copy this one right here, because I don't want the friend and I don't want the function definition here. I just want my plain old template. So paste that in, and instead of a semicolon, I am going to put parentheses in. So I have my OStream ampersand operator. There's the operator I'm going to overload is the extraction operator. I have my out operator, and I have a reference to my linked list. Okay, so all I have to do in this is update my out operator. In order to do that, I have to have a pointer to my current node. So current node equals, now I can't just say front, because technically since this is a friend function, we're not in the class, but I do have a parameter to my class. This is list. So I can say list.front. Now I have the front of the list. And since front is a protected variable, I have access in the friend function. Okay, so so long as my current node exists, I want to display the information. So I'm going to say out. I'm going to display my current node data. Now, if it's not the end of the list, so if current node arrow next, if there is a next value, meaning if this is not the end of the list, I'm going to add just a single space. If it is the end of the list, then current next will be null and it won't run through this if statement. Okay, so I've got the current value. I need to move my pointer to the next position in the list. So current node equals current node arrow next. There we go. Okay, so this parenthesis right here ends the if, and if, I'm going to put a little comment there. This little bracket right here ends the while. I need to return my OStream operator, and then this particular bracket ends the method. And that is theoretically it, other than instead of putting out, I put cout, so I do have to fix that. I'm using this out operator instead of cout. And let's just test this, make sure there's no errors. Bring this up, 0 errors, 0 warnings, that's amazing. And then it's passing all my tests, so I'm good. We now have a working linked list class that you can use to override for the next assignment. Okay, good luck. Let us know if you have any questions, and we will see you another time.